All right. Hey, everyone. Welcome back to the deep dive. You're here because staying in the know, keeping up on this stuff, is how we make smart choices, right, for ourselves and our families. And that's exactly what we're doing today, getting into something so incredibly common. We all use them, plastic food containers.
Yeah, they're everywhere, aren't they? We dug into some recent research on this, and it's pretty eye-opening. There's this study that really breaks down what's going on with these everyday containers, specifically looking at the release of microplastics and nanoplastics. And it's honestly information you'll want to have if you use plastic, for storing or reheating food. Pretty much all of us, I'd imagine.
Definitely worth paying attention to. So microplastics, nanoplastics, these terms get thrown around. But before we jump in, could we clarify what exactly are we talking about here?
For sure. So picture these microplastics are these little bits of plastic less than 5 millimeters across, so tiny, some you can almost see. Now, nanoplastics, those are the really, really minuscule ones down at the nanometer scale, like way too small to see with the naked eye. This particular study, they were looking at how these particles basically break off from those everyday plastic food containers and those kind of flimsy pouches and end up in our food and drinks.
Okay, so our mission here on the deep dive is to take that sciencey stuff and break it down, make it real for your daily life, right?
Right.
Cut through the jargon. This study, and it's something our source material really highlighted, had some pretty shocking stuff about how these particles get released, especially when we're storing food in plastic or heating it up.
Yeah, no sugarcoating it. The main finding is pretty clear-cut. Those plastic containers, they do release both microplastics and nanoplastics into the food they're holding. And the thing is, it's not like a super slow process over years. It's happening with regular use every day, even just popping leftovers in the microwave.
And the study really zeroed in on microwaving, didn't it? Those results were kind of alarming.
Oh yeah, for sure. Microwaving seems to be a major culprit here. They found that heating stuff in the microwave led to the biggest release of these plastic particles. Like, we're talking potentially up to 4.22 million microplastic particles. And get this, a whopping 2.11 billion nanoplastic particles per square centimeter of the container. That's an insane amount.
Billions with a B per square centimeter.
Yeah.
To put that into perspective, that's almost impossible to grasp. And they were specifically looking at a 3-minute test at max power.
Right.
Pretty standard for most of us when we nuke leftovers or that quick lunch.
Right, exactly.
Yeah.
That 3-minute zap in the microwave, something so many of us do daily, seems to be a huge factor in how much of this stuff gets released. But it's not just the intense heat of the microwave. They also looked at what happens during more like passive use, just storing food.
Okay, so even if it's just sitting in the fridge or on the counter at room temperature.
Yep. They basically recreated what happens during longer-term storage by keeping the containers at different temperatures, fridge temp, around 20 degrees Celsius room temp, which is about 40 degrees Celsius, and even hotter at 70 degrees Celsius. And they used liquids that mimic food water for more neutral stuff, and a 3% acidic acid solution to represent acidic foods like, vinaigrettes or tomato-based things.
And what came out of those longer storage tests? Was there still a significant amount of particle release?
Yeah, the results showed even with just storing stuff over time across all those temperatures, millions of plastic particles were ending up in those food-like liquids. It's not just the nuking, it's the material itself shedding these particles over time. Makes you think twice about those takeout containers in the back of the fridge, right?
Definitely food for thought. So it seems the type of plastic used also played a role, according to the study.
Yeah, that's a really important point. The researchers found that those softer, more flexible pouches, the ones often made from polyethylene, they tended to release way more particles than the more rigid containers, usually polypropylene. So yeah, the type of plastic definitely matters in terms of how much it breaks down and sheds those particles. We're thinking twice about those takeout containers before we reuse them or heat them up.
This is getting pretty concerning, especially when we consider, who might be most vulnerable. The study specifically looked at infants and toddlers.
Yeah, that's where the potential health implications get really serious. They calculated estimated daily intake for infants who might be drinking, water that's been microwaved in polypropylene bottles. And the findings suggested an intake of up to 20.3 nanograms of microplastics per kilogram of body weight per day.
To help visualize that, they used a 9-kilogram infant as an example. So that baby could potentially be ingesting about 182.7 nanograms of these microplastics daily just from their water if it was microwaved in that type of bottle. It's a tiny amount, but for a little body.
Right, and for toddlers who are eating, microwave dairy products, those estimates went up a bit to about 22.1 nanograms per kilogram of body weight daily. So an 11-kilogram toddler, we're looking at potentially 243.1 nanograms of plastic every day. Given their size and, still developing systems,
Hmm.
that level of exposure is something to be mindful of. It really highlights how we feed them matters.
Absolutely. So the study also looked at potential health risks on a smaller scale, like right down at the cellular level.
And this is where things get interesting. They did what's called in vitro testing, basically, in a lab setting. They exposed human kidney cells to those microplastics and nanoplastics they extracted. And what they saw was up to a 77% cell death rate after 48 and 72 hours of exposure. They used a specific type of human embryonic kidney cell called HEK293T. Now, keep in mind they used higher amounts than what we typically ingest, but the takeaway is these tiny particles can mess with how our cells function, at least in a lab setting. It's a red flag we can't ignore.
So pretty significant impact in the lab. But the study did point out that those concentrations were higher than what we normally find in our food, right?
Right, and that's super important to remember. The levels of microplastics and nanoplastics in those lab tests were higher than what's typically found in the food we eat. So while the results suggest there could be harm at the cellular level, the actual risk in our day-to-day lives might be different. The researchers themselves stressed that we need more research to really get a handle on how these particles build up in our bodies over time and what the long-term effects might be. It's a developing area of research.
It's an important reminder that this is all ongoing research. So to give us a peek behind the curtain, how do they actually do these tests?
Well, as we talked about, they mimicked different storage conditions, with those different temperatures and the food simulating liquids. And for the microwaving, they used regular plastic containers filled with those liquids and zapped them at full power for 3 minutes. But the really cool part is how they analyzed the particles that were released. They used some really sophisticated imaging and spectroscopy techniques to count those particles. And this is key to figure out exactly what kind of plastic they were. For example, they use something called Raman spectroscopy. It's a method that uses light to identify a material's chemical fingerprint so they could be absolutely sure they were measuring plastic and not something else.
Not just guessing, but actually pinpointing the type of plastic. That adds a lot of credibility to the findings. Okay, so we've established that plastic containers can release these tiny particles, especially when heated. What are some practical steps we can take based on this research?
This research really points us towards some clear actions to reduce our exposure. The biggest one, the most impactful, is to switch to safer alternatives whenever possible. Think about using glass or stainless steel for storing food, and especially for heating it up. And when you need something portable, those certified food-safe silicone products are a good bet, way better than traditional plastics.
That makes a lot of sense. Glass is pretty much inert, right? It's not going to leach into food like plastic can.
Right.
What other practical changes did they suggest?
Another biggie is to rethink how you're preparing your food, particularly heating things up. Try to avoid microwaving anything in plastic containers. That simple step of transferring your food to a microwave-safe glass or ceramic dish before you heat it up can make a real difference. Also, they suggest reusable beeswax wraps or those stainless steel lunch boxes instead of plastic bags or pouches, which just helps cut down on plastic use overall.
Yeah, good straightforward swaps for a lot of us. What about the plastic containers we already have? How should we be handling those?
Be mindful of temperature. Avoid putting your plastic containers in really hot places like the dishwasher or direct sunlight, because heat can really speed up the release of those particles. And if you do need to use plastic, try to choose ones that are labeled BPA-free and heat-resistant. They might be a slightly better choice, although the study still showed they release particles.
And they had some specific advice for parents of young children, right?
Absolutely. Because of that potential vulnerability of infants and toddlers, those recommendations are especially crucial. They suggest avoiding plastic bottles and containers completely when you're preparing formula and going with glass feeding bottles or stainless steel instead. And same goes for serving any warm food or liquids to little ones. Use non-plastic containers. It's a good precaution to take.
So it sounds like the overall message is to move away from using plastic gradually, especially for heating food or storing it for a long time.
Exactly. The advice to go plastic-free gradually makes it feel much more manageable. Start with small changes, like replacing one plastic item in your kitchen every week. Over time, those small steps add up to a big difference. They also mentioned trying DIY solutions, like making your own snacks, so you're not relying on those prepackaged foods that often come in plastic.
So individual choices at home and just a broader awareness of the issue. What else can we do beyond our own kitchens?
There's definitely more. We can spread the word, share this information with friends and family to help more people understand the potential risks and encourage healthier habits. And supporting businesses that are using sustainable, safe packaging that sends a message too. And always read those labels on plastic products carefully. Pay attention to the recycling codes. Try to steer clear of plastics with the numbers 3, 6, and 7, unless they specifically say BPA-free, it all helps.
A multi-pronged approach.
Yeah.
So to wrap up our deep dive, what's the key takeaway you want listeners to walk away with?
The main point here is that those everyday plastic food containers we all use, they release potentially harmful microplastics and nanoplastics into our food and drinks. And that release increases a lot when we heat them up, especially in the microwave.
And while we're still learning about the long-term health effects, it's smart to take precautions, especially since there are good alternatives out there. We've covered a lot of practical steps today, things listeners can start doing right away.
Exactly. Even something as small as grabbing a glass container instead of a plastic one when you're reheating leftovers can help reduce your exposure and your family's exposure. And if you want to stay informed about important research like this, all broken down in a way that's easy to understand, check out our free weekly newsletter at boostgb.com. It's a great way to keep learning and stay in the know without getting bogged down by all the technical details.
So thinking about everything we've talked about, what's one swap you might make in your kitchen today? It's worth considering. Thanks for joining us on The Deep Dive. We'll see you next time.